Hello, let us find the derivative of x squared using the first principle. Okay, let's say y is equal to x squared, that is y is a function of x. So y is a function of x. So that when x changes by some amount, when x changes, increases or decreases, it causes y to change as well. We're not gonna go in the detail. Let's just say it's just a relation. So that if x changes, y changes. Let's not go into the detail that if x increases, y decreases. No, just change. If x changes, then y changes. Okay, it can be in any direction. So that's basically what's the definition of a function, a relation. Okay, function is like a machine that converts one thing into another. Okay, so let's say y is a function of x. Y is equal to x squared. So when x is changed by a small amount, when x changes by, let's say, partial x. So initially x has this value, and after some time x becomes x plus partial x. Okay, so basically what happened here, x squared after some time has become x plus partial x squared. Okay, so what will its impact be? What will its impact be on y? How y will behave? Okay, if this happens. Okay, if this happens, how will y behave? So let us write it in equation form. Initially y is equal to x squared. Let's call this equation 1. Okay, so after some time, as x changes from x plus partial x, the function y changes, also undergoes some change, and this small change is represented by partial y. So y has changed by partial y. Okay, let's call this equation 2. Now subtract 1 from equation 2. Okay, so what we get? We get y plus partial y minus y. That's on the left hand side, and on the right hand side we're left with x plus partial x square minus x square. Okay, so we're gonna expand it here. Okay, this y will cancel this y out, and we're left on the left hand side with partial y, and on the right hand side, let's expand this square. It will be x plus partial x square plus partial x square plus 2x, 2 times x times partial x, and minus x square. Okay, now this x square minus x square, this x square, this minus x square will be cancelled out by this x square, and this, you know, this will and 2x plus 2x partial x plus partial x square will remain on the left hand side, right hand side. So let's move to the next. I'm gonna erase this and so continuing from here, so partial y is equal to 2x partial x plus partial x square. Okay, so dividing both sides by partial x will give us 2x partial x divided by partial x plus partial x square divided by partial x. Okay, this will cancel out, and this will leave us partial x. So it will become partial y by partial x is equal to 2x plus partial x. Okay, now we want to find the derivative, and by definition of derivative we know that derivative of a function is equal to dy by dx is equal to partial y by partial x, where limit partial x tends to 0. So okay, so it is a rate of change when the change is very minute. Okay, so we're gonna drag it here, and so we apply the limit on partial y by partial x. Limit partial x tends to 0 on the left hand side, and 2x plus partial x, limit partial x tends to 0. Now if we apply this limit, the left hand side will become dy by dx, the definition of derivative, and the right hand side, when we put partial x equal to 0 here, okay, so it will become 2x. so that's the derivative of, so dy by dx or d over dx x square is equal to 2x. So that's the derivative of x square by the first principle. That's all for today. Thank you.